All right, today is section 3.3, dividing polynomials. So for anyone who is bored with this class up until now, I've got really good news. We're about to become unbored real quick. Right? We're about to do some crazy things starting this section. This section's not going to be so bad, but the sections following this one, we're going to start getting into things where you're just like, ooh, this class sucks, if you're not at this point already, right? But anyways, let's go. Okay, so what does that say? So let's read it. So far in this chapter, we have been studying polynomial functions graphically. Okay, so we've been looking at polynomial functions on a graph. In this section, we begin to study polynomials algebraically. Most of our work will be concerned with factoring polynomials, and to factor, we need to know how to divide. So let us fit all that. Let's look here. Okay. All right, so long division of polynomials. Dividing polynomials is much like the familiar process of dividing numbers. When we divide 38 by 7, the quotient is 5 and the remainder is 3. We write like this. So again, 38 divided by 7, okay, is 5 plus, the remainder, right? If you recall, let's do this. Let's do 10 divided by 3. If you recall, when you did this, you would say 3 with a remainder of 1, right? Y'all remember doing that? Of course, we stopped doing that many years ago, once you learned how to do other things. But that's what we did. So talking about remainder there. But looking at the anatomy here, we have the dividend, okay, the number that we are dividing by. We have the divisor, the number the number that is being divided is 38, and the divisor is the number that we are dividing by, okay? And then of course the quotient is your whole number, like what you have whenever you do divide the dividend by the divisor. And then you have the remainder, okay? Notice the remainder is this 3 up here, okay? And beneath it, the 7 is also the divisor. So you could say this as if we divided this, we would say the quotient plus remainder over divisor. Okay, and that's important because we're going to be doing the same process here. So looking here, if p of x and d of x are polynomials with d of x not equal to 0, then there exist unique polynomials q of x and r of x, quotient and remainder, where r of x is either 0, okay, that would be a remainder of 0, or of degree less than the degree of the divisor, such that this, okay. So just to break this down and make it look like this over here, we have this polynomial. We have a polynomial, some polynomial over some divisor. Same thing here, some number over divisor. Okay. It will equal to the quotient, which is the same thing here, and then plus the remainder, okay, which is the numerator there, over the divisor, which is here. Okay. And of course, if we cleared the fractions, looking here, if we looked here, we cleared the fractions, we'd multiply both sides by d of x, right? So we multiply both sides by d of x. Well, that would clear this, and that would multiply this by d of x, and that's what you see here. Okay. So the polynomials p of x and d of x are called the dividend and divisor respectively. Q of x is the quotient, and r of x is the remainder. Okay. So we're going to be following along with that. Long division of polynomials. So this is where we're about to get bad, about to get nasty. Okay, here we go. So if I were to be in the process of dividing polynomials, okay, I'm going to be starting the same way I do if I was just dividing, normal numbers, right? My divisor here is x minus 4. My dividend is 6x. Okay, so a couple things. Whenever you write the dividend and the divisor, Okay, you want to write the dividend and the divisor like you would any polynomial in descending order. Okay, and furthermore, if and I don't know if I'm sure we do, but furthermore, if you are missing a power, so like if we had a dividend, be a fourth degree polynomial, so it'd be 6x to the fourth, plus let's say 3x squared, then we would write 6x to the fourth here, 6x to the fourth, and then we'd say plus 0x cubed, okay, because we're going to need a filler so we can have this area up here to write in. Okay, so make sure that whenever you do, and I'm pretty sure we'll have an opportunity to see that in this section, but just in case we don't. Okay, this polynomial is written nice and neat, so it is 6x squared. It's a secondary polynomial, so minus 26x plus 12. Okay, all right, so here we go. When you divide polynomials using long division, this is what you do. You're going to look at the first term in both cases. Okay, so I'm underlining. I'm going to underline this and this. Okay, and I'm going to do that arithmetic out here to the right. So it's 6x squared divided by x. I'm just dividing there. Okay, well 6x squared divided by x is what? Well, it is equal to 6x. Okay, so since it's equal to 6x and it's a first degree polynomial, okay, I'm going to put the 6x above the x here. Okay, now do you have to do that? No, not if you don't want to, right? I mean, if you want to, you can put 6x here. Okay, but the reason why I put it above the same degree is because it helps me keep my ducks in a row, and you'll see why later on. Okay, so anyways, now what we're going to do is we're going to multiply this 6x by this x. Okay, well, what is 6x times x? Well, that is 6x squared. So we're going to put 6x squared. Should I put it beneath it? No, we'll turn it into white. Okay, so 6x squared here, and then 6x times this negative 4. Well, that's going to be a negative 24x. Okay, let's fix that. Negative 24x, and then the 12. There's nothing else I can do. So here's the big point of long division. Okay, when I put this equal sign beneath here, as soon as I'm done putting this equal sign, I'm going to change the sign of the numbers above it. Boom, boom. Okay, so let's do that again. I'm going to put the equal sign there, and then as soon as I put the equal sign, I change the sign of the numbers above it, so that positive 6x turns into a negative 6x squared, and that negative 24x turns into a positive 24x. Okay, and then I'm going to do that arithmetic. Okay, well, 6x squared, right? 6x squared minus 6x squared, well, that's 0, right? And that's what I'm looking for. If you get anything other than a 0 in this spot, you did it wrong, 100%. Okay, so I want that to be a 0. Well, now then going over here, I've got a negative 26x and a positive 24x, so I've got a minus 2x, and then I've got a plus 12. Okay, and now I repeat the process. So now what I'm going to do is I'm going to look at this term and this term. Okay, same thing I did when I did the 6x and the x. All right, so I'm going to look at the negative 2x. So I'm going to write negative 2x divided by x, and that's equal to negative 2. Okay, so that negative 2 constant, I'm going to put above the constant here. Okay, and then I'm going to multiply through. So I've got negative 2 times x, which is negative 2x. Negative 2 times a positive 4, which is a plus 8. Okay, and then same thing, guys. I'm going to put this equal sign here, and then I'm going to change the sign of everything above it. And just to really drive the point home, I'm going to just mark that out and put a negative right here. Okay, instead of erasing it, put a negative sign there. So that's it. and then I'm going to do the arithmetic. So I'm going to look here, okay, and I got a 0. Perfect. So I know I did it right, okay. And then I got a positive 12 and a negative 8, so I've got a 4. And then I can start again, okay. And then I'll do here. I'll look at here the 4 and then the x again. Okay. By the way, it's always just the first term of your divisor. Okay. So I had 4 over x. Well, 4 over x is 4 over x, right? So I'm done. Okay. So my solution I would write in quotient plus remainder over divisor. Okay. So let's erase that. Maybe, okay, I'll put solution right here. So the solution, okay, is quotient. So my quotient is right here. So 6x minus 2, quotient plus the remainder, so plus my remainder, which is 4, over my divisor, which is x minus 4. Okay, and that's my solution. That's my solution in the problem is wanting us to put it in the two forms shown in the above box. Okay, so it's wanting us to put it, and we just did it in this form. The next form would just simply be multiplying both sides by the divisor, right? So let's say for the sake of it, maybe I can just snip the solutions. Yeah, we'll just do that because I'm kind of running out of room. We'll put it right here. Okay. And of course, what we did was this one. Okay. The other form would just be multiplying it by the divisor on both sides. Okay. So that's it. I say that's it, but I mean, I know it's a long, tedious process. But I'm gonna be honest with you. So I mean, I don't like fractions. I don't like decimals. You know, I'm kind of like you. You know, but I really do feel like long division of polynomials. You know, I wouldn't go so far as to say it's fun. I would just say it's not as bad once you really start to understand what you're doing. Okay, so let's do this one. All right, so my divisor is 2x squared minus x plus 2. And then my dividend, okay, my dividend is what I was saying earlier. Okay, so it's a 4th degree polynomial, so we're going to write 8x to the 4th. X to the 4th. And then there isn't an x cubed, okay, but because I like things nice and neat, I'm going to put a 0x cubed right there. Okay, and then plus 6x squared minus 3x. I can tell this is going to be a problem. Plus 1. All right, let's make sure we get examples that don't fit on my screen. That's good. All right, so what color did I start with? Was it blue? Nice, blue. Okay, so it wants us to find the quotient and remainder such that, and of course, we'll do that. All right, anyways, so we're going to look at the first term here. Okay, so we're going to have 8x to the 4th power divided by 2x squared, and that's going to be 4x squared. Okay. So I'm going to write 4x squared right here above the x squared. Again, right here above the x squared. Try to keep things in line there. And then I'm going to multiply through. Okay. So by multiplying through, 4x squared times 2x is an 8x to the 4th. Multiply 4x squared times a negative x, so I got a minus 4x cubed. 4x cubed. Okay, and hopefully you really see why putting in that filler really helps. Okay, because if I didn't have this 0x cubed right there, then I'd be putting this negative 4x cubed. You know, I'd probably be putting it under that 6x squared, wouldn't I? And then I feel like things would be a little confusing, right? So it does help to keep things in order there. So anyways, 4x squared times 2, which would be an 8x squared, so plus 8x squared. Okay, and then same thing, guys. I'm going to put my equal sign, and then I'm going to change the sign of everything. Okay, so we're going to do equal sign, and immediately change the sign. So that goes to negative, that goes to positive, and this, again, I could erase it, but just to really drive the point home, I'm going to mark it out and put a minus sign. Okay, and then I'm going to do the arithmetic. Okay, well, that zeroes out. Perfect. That's what I want. We're on the right page. This is a 4x cubed. And then we've got a minus 2. Ooh. Whenever it auto saves, it just kind of janks up my writing. Minus 3x plus 1. All right, let's do it again. So we will have, we're looking at this term and this term again. It's always the first term, okay? So we'll have a 4x cubed. Okay, we'll put here 4x cubed divided by 2x squared. Okay, and that gives me what, a 2x. We're going to put a plus 2x there. And then we're going to proceed with the multiplication process. So we're going to have 2x times 2x squared. So we're going to have a 4x cubed. And again, that's what I'm wanting there. That's good. And then I have a negative 2x squared. Well, that's nice and convenient. And they're going to have a plus 4x. And then I put my equal sign and change the sign everything right above it. Boom. Okay. Well, doing my arithmetic, those cancel, that cancels. So I've got a negative 7x plus 1. And of course you can see that we're going to have to stop there though, because if I look at this and this, then it would be negative 7x divided by 2x squared, which is doesn't happen evenly. So we can end there, and it wants us to find the polynomials Q and R such that we have the divisor. Right, divisor. Yeah, the divisor. Yeah, divisor is the D, right? P would be the dividend. Yeah, sorry. Where we have the divisor times the quotient plus the remainder. Okay, so I'm looking right here. Okay, so it's saying P of X. So it's P of X is equal to D, which is the divisor, times the quotient plus the remainder, which, if you forgot, oh man, I could have, oh, whatever. But if you forgot, it's just this here, okay? The divisor times the quotient plus the remainder. Divisor times the quotient plus the remainder. So what is my divisor? Well, it was, let's put this down here for solution. My divisor was 2x squared minus x plus 2. All right, it's multiplied by my quotient, which is up here, 4x squared plus 2x. All right, I don't have room, so I'm gonna snip it. Is that okay? I'm gonna snip it. I don't want to put the remainder on another line. Okay, so that's the solution. Okay, which again is the divisor, which is here, the quotient, which is here, and then the remainder, which is here. And again, all this does is follow along with the one of two ways to write the solution that we saw on this page. This is the first way, and this is the second way, which we did just now. Okay. All right, so as you know, or as you maybe are familiar with, there is a faster way to do division of polynomials, okay? But don't get your hopes up, because it only happens on special cases. Okay, so let's read this. Synthetic division is a quick method of dividing polynomials. It can be used when the divisor is of the form x minus c. In synthetic division, we write only the essential parts of the long division. Compare the following long and synthetic division, in which we divided divide 2x cubed minus 7x squared by x minus 3. Did we do that earlier? No. Okay. But anyways, so this is just a quick little, this is essentially just another example of long division, right? But notice how we are dividing this third degree polynomial here, this third degree polynomial by x minus 3. Okay, we can go about doing the long division, and there's nothing wrong with it except for it's long, right? Whereas if we use synthetic division, right, we would just have to write this, and then we do indeed get the same solution, right? So the quotient here is the same quotient here. The remainder here is the same remainder here. Okay, so as you're familiar with, synthetic division is easier and faster and simpler and better looking than long division. But the bad news is that you can only do it in special cases. And that special case is only when you have a divisor of the first degree. Okay, so for instance, this example, I have a divisor of a second degree polynomial. I could not use synthetic division. This one, I could use synthetic division because my divisor is a first degree polynomial. Okay, so anyways, note that in synthetic division, we abbreviate 2x cubed minus 7x squared plus 5 by writing only the coefficients. Okay, but we're writing them in descending order, right? 2, -7, and 0. Oh, and 5, sorry. 2, -7, 0, and 5. And instead of x minus 3, we write we change the sign of that positive 3. We would change the sign of here of this -3, x minus 3. We would change it to a positive 3. Okay, so the next example shows how synthetic division is performed. So let's go ahead and start on that next example. So I can, again, I can use synthetic division because I have a divisor raised to the first power. Okay, so how do we set this up? Here's what we're going to do. We're going to write my divisor first, so it's an x minus 3. Okay, so since it's a minus 3, I'm going to put a positive 3 right here. Okay, I'm going to change the sign of that, and then I'm going to put a little boxish around it. Okay, and then I'm going to write just the coefficients in descending order. Okay, descending according to my degrees, right? Not descending in terms of like 10, 9, 8, 7, 6, 4. So we're going to write 2 x cubed. Okay, yeah. So 2 is x cubed. We have a -7 for the x squared. Sorry. So we have -7 for the x squared, but we don't have anything for an x, do we? There is a missing x. Well, same as before, you need to account for that, okay? So we're going to put a 0 as a placeholder for x to the first power. So again, this is essentially x cubed, x squared, x, and then, plus 5. Okay, so that's what I'm doing. I need to account for each and every single one of those powers, even if they do not exist in the original equation. Okay, and then what, we have a positive 5. Nice. Okay, so I'm gonna put a little line down here. I do it naturally, right? I do it differently than the book does it, but we get to the same place. Okay, but do it the way I do it. Promise it'll work. So here we go. First things first, what I'm going to do is I'm going to just immediately put that 2 down here. Okay, and then what I'm going to do is I'm going to take this 2 and multiply it by this 3. So 2 times 3 is 6. And then I'm going to do the arithmetic. Well, what is -7 plus 6? Well, that's -1. What's -1 times positive 3? Well, that is a -3. -3 and 0 is a -3. And then -3 times 3 is a -9. And then a 5 and a -9 is a -4. Okay. And by the way, we're going to put a little box right there as well. Okay. So what did I just do? Okay, so here's what's happening. I am taking this polynomial and I'm dividing it by x minus 3. Okay, so here's what we're going to do. We need to look at this and say, okay, so this is a third degree polynomial. Okay, so since it's a third degree polynomial, my quotient is going to be a second degree polynomial. Okay, because I'm taking a third-degree polynomial and I'm dividing it by a polynomial raised to the first power. So this is going to be a second-degree polynomial. So I'm going to start with x squared. I go down to x, and then negative 3 is a constant, and then negative 4 would be the remainder. Okay, so if I were to write this in if I were to write this in quotient plus remainder over divisor, I would say, okay, so my quotient is 2x squared minus x minus 3, my quotient plus my remainder, which is negative 4, over my divisor, which is x minus 3. Okay, and that's that, right? But of course, if we wanted to write this in the other form, it would be the quotient 2x squared minus x minus 3, the quotient times the divisor, and that is not equal, but then minus the remainder, because it would be plus the remainder, and the remainder was negative 4, so it would be minus 4. Okay, so those are the two forms that we write this. And of course, this is a lot easier than all this, isn't it? Okay, and it definitely is, but again, you can only do it for a special case. That special case being that your divisor is raised to the first power, unfortunately. All right, now we're gonna get to some fun stuff now. I'm telling you, this is where this class takes off. This is where you drop the class. All right, so first thing we're talking about is the remainder theorem. Okay, the remainder theorem is gonna bring us into the factor theorem, and that's the main thing we're going to be using for the next few sections to factor polynomials that are higher than degree 2, right? So the remainder theorem, this reads, if we have some polynomial and it is divided by x minus c, okay, then the remainder is the value of that polynomial at that value being divided, okay? Or I'm sorry, at that constant of the, okay, let me just read it, and then I'll try to reword it in my own way, okay? So if the polynomial p of x is divided by x minus c, then the remainder is the value p of c. So we have x minus c, okay? If we divide by x minus c, the remainder will be that polynomial evaluated at that constant z of c, okay? So if you recall in the previous section, I said, these four statements are equivalent. As essentially, I won't say it's restating it, but it's essentially saying, if we divide some polynomial by, we have the divisor x minus c, then the remainder is going to be the exact same value, okay? The remainder being, the remainder is going to be the exact same as the polynomial evaluated at negative 4. And as a matter of fact, I'm glad I went back. So if I took this polynomial, okay, and I evaluated it at negative 4, okay, well then from the remainder theorem, the remainder is the same value of p of c. And I think I'm getting confusing, so let's do an example. I do that a lot, I know, I'm really sorry. Okay, so we need to do this. So we're going to do the synthetic division. So we can do synthetic division because A reads, find the quotient and remainder when p of x is divided by x plus 2. Okay, so if it's x plus 2, I know I can put the negative 2 right here. Okay, so I put a little box there. And then I'm going to write all the coefficients out of this polynomial. Okay, and it's a fifth degree polynomial. It looks like we're skipping x squared, so make sure to put that 0 for x squared. Okay, so we're going to have a 3, a 5, negative 4, that's cubed. We're going to have a 0 for the x squared, a 7, and then a 3. Okay, we'll put this little line here, and then we'll put that box there. So let's do the synthetic division. Again, we just bring this down, so 3, and then 3 times a negative 2 is negative 6. We have negative 1, we have 2, we have -2, we have 4, 4, -8, -1, which is 2, which is 5. Okay. So we found the, all right, so the quotient and remainder. So the quotient here will be, so again, it's a 5th degree polynomial. So the quotient will be 3x to the 4th, one less, minus x cubed minus 2x squared plus 4x minus 1, okay? And the remainder is going to be 5. That's the remainder, okay? So what this is saying, or what the, oh, I did say that backwards. No wonder I was confusing myself, okay? So what this is saying is if I evaluated this polynomial here, all right, if I evaluate this polynomial here at -2, then I will get 5, okay? And okay, so lucky for us, it doesn't actually do it, but you're more than welcome to put into your calculator. I mean, I have a pretty good calculator, and I told you I use Math Labs on my phone, and all I would do here is I would say I would do, and I'll write it up. How about that? I'll at least write that. I would say P of -2. Dang, I'm gonna run out of room. Okay, we'll just stick with this. We'll say P of -2 is equal to 5. Okay, so by the remainder theorem, if I evaluated my polynomial at that value right there, P of -2, then I will get the remainder. Okay, that's what the remainder theorem states. Okay, so that leads into the big dog of this particular section and the theorem that's going to carry us for the next few sections. And that is the factor theorem. Okay. So, factor theorem. C is a 0 of P. Okay, so we're stating that C is 0 of P if and only if x minus C is a factor of P. Okay, so what this is saying is that we had that some constant will be a 0 of P. Remember, a 0 would be shoot. Let's say we have f of x is equal to x minus 3 x plus 2. Okay, so for this one, a 0 of this function, okay, and actually let's go ahead and let's keep consistent with the section. We'll call it p of x. Okay, a 0 of this polynomial would be a positive 3 and would be a -2, right? Because if I plugged in a positive 3 here, I get 3 minus 3 and that'd be 0, right? So those are a 0 of this polynomial. Okay, and again, if you recall, the if and only if statement means that I can read it pretty much frontward and backwards. So I can say C is a 0 of P if and only if x minus C is a factor of P, and x minus C is a factor of P if and only if C is a 0 of P. Okay, again, this isn't anything groundbreaking. This isn't anything abundantly new. It's just kind of restating kind of something we already know, right? That if we have a 0 of some polynomial, then it's also a factor, right? We've done this before. We just kind of worked backwards. Again, just a recap. We have written polynomials like this in factored form, right? And then we would say, okay, x equals x equals 0. We set this equal to 0 from the zero product principle, and then we would end up with 3, right? Same thing here, zero product principle. We'd end up with -2. That's something we've done before. It's just we're kind of restating it using the factor theorem. And it's going to lead into being able to factor crazy polynomials. Okay, so let's actually get into factoring a crazy polynomial. Perfect. So this also is going to lead into what are we doing this nonsense for? Well, let's do this. Let's do this nonsense, okay? So if we have this polynomial p of x is equal to x cubed minus 7x plus 6, okay? So just right off the bat, if I said factor this polynomial, what would you do? Okay, well, it's a cube, right? So we can't do any sort of tricks that we do with quadratics, right? We can't just straight up factor it. We can't do the quadratic formula. We can't do substitution. We can't do any of the tricks that we know, right? Furthermore, looking at all three of these, there's nothing that I can factor out of all three of them, and kind of make it easier, right? So we can't do that either. It's not 4 terms. We're gonna be factored by grouping, so you're gonna be stuck. You're gonna be like, nope, I don't know. I don't know how to factor this at all. Okay, so here's what we're gonna do. This particular problem, okay. So real quick, I'm pretty sure the next section, a section after, we'll be able to look at this, do some crazy arithmetic, and it's gonna suck. All right, so be prepared, and we're gonna be able to factor it into what we're about to factor it into. Okay, but for now, since we're being introduced to it, we are already told what a factor is. Okay, 1. Right? So we're already told what a factor is. So what we're going to do here is, since we are told what a factor is, recall that, p of 1 there, okay, is essentially a factor that looks like this, x minus 1, right? Because oh, did I erase it? Yeah, well, yeah. All right, let's talk about it from here. So this is going to be a factor of this polynomial from our factor theorem. Okay, it's going to be x minus 1 and then some other stuff. But x minus 1 is definitely a factor of this polynomial because p of 1 is equal to 0. Okay, now I'm telling you now, you need to, you're going to be on fall break. You need to be able to look at this section, wrap your head around it, frontwards, backwards, left and right, up and down, doesn't matter, okay? This is complicated stuff today, and if you do not understand it moving forward, you are going to fail at least chapter 3, okay? You don't want to do that. So understand this all the ways around. Email me, talk to me, set up Zoom sessions, because this is very complicated. Just trying to fit these puzzles together, or puzzle pieces together. But once you fit the puzzle pieces together, you're going to be all right. Okay, so let's just begin. I know that p of 1 is a factor of this polynomial. Okay, and it's got a remainder of 0, or p of 1 is equal to 0. So that means when I divide this polynomial, I should put it in white, stay consistent. I'm going to get the remainder of 0, and my quotient is going to be what I multiply that factor by. So this is a third degree polynomial, so I know I can write this as a 1, and then the x squared is skipped, right? So I need to put a 0 there for x squared, minus 7, and then plus 6. We'll get the equal sign here. We're going to bring this 1 down, and we're going to begin. 1 times 1 is 1. We got 1. 1 times 1 is 1. We got that. We got negative 6, and I forgot to do this again. And then 1 times negative 6 is negative 6. And then sure enough, we do indeed have that remainder of 0. Okay, but what is this telling us now? Okay, so this is telling us my polynomial p of x, okay, p of x being x cubed minus 7x plus 6. Okay, knowing my factor theorem, I can factor this into x minus 1. Okay, that x minus 1 comes from the knowledge of this. P of 1 is equal to 0. Okay, that tells me that is the factor. Okay, and then I'm going to say, okay, so this is a third degree polynomial. I factored it by a first degree polynomial, so this would be an x squared and an x. Okay, so I'm going to just write the quotient, and I guess I'll put it in blue to really drive the point home, I guess. So I'll say x squared plus x minus 6. Okay. So now I have factored the x cubed minus 7x plus 6. I factored it into this. And of course, I know that the x squared plus x minus 6 can also factor even further So x minus 1, and then it looks like what, a positive 3 and a negative 2. So there it is. Using my factor theorem and using the knowledge here, p of 1 is equal to 0. Okay, p of 1 equal to 0 tells me that this, okay, is a factor of the polynomial. Okay, since that's a factor of the polynomial, and I know that I can put the in because I know the remainder is 0, right? Because we're told, you know, p of 1 is equal to 0, and then from the previous slide, using the factor theorem, if we have c is a 0 of p, then x minus c is a factor. So going all around here, I can do the synthetic division here. This p of 1 goes here, okay? And then all this is just my dividend there, essentially, right? My polynomial is there. I do my synthetic division, and by the way, you can always do synthetic division moving forward in what we're about to do when we begin the factoring process. Okay, we do the synthetic division, and then of course, you know, we do the whole, you know, this is x squared, this is x, and then we can transplant this as a factor of my polynomial as well. Okay, and then of course, x squared plus x minus 6 also factors. So at the very beginning, I said, hey, let's factor this. And your eyes are like, I don't know how to do that, right? Well, we just learned how. And that's the good news, I guess. We just learned how. The bad news is it gets way more complicated, okay? So I promise you, if you do not understand this lecture, luckily it's recorded, rewatch it. Luckily, I have a phone glued to my hand, email me. Okay, but if you do not understand this section, you are going to fall behind very, very quickly. Okay, and lastly, this is, in my opinion, this is kind of a fun exercise. Don't you just hate that I say that? Because you're like, this isn't fun. But yeah, this is kind of a fun exercise. All right. So, and I think it's a fun exercise that really drives the point home of what we're doing as well. Okay. So let's do this. It says find a polynomial of degree 4, okay, that has zeros at -3, 0, 1, and 5, for which the coefficient of x cubed is -6. Okay, so this isn't going to be too bad. So we're going to find a polynomial. So we're just going to name this polynomial p of x of degree 4. Well, that of degree 4, it's kind of going to just come to fruition on its own when we do our zeros, right? So if we have a 0 at -3, how do I write that in factored form? Well, I write that in factored form as x plus 3. I have a 0 of 0, so that's just going to be an x, okay? I have a 0 at +1, so I'm just going to write that in factor form as x minus 1. And then I have a 0 at +5, so I'm going to write that as x minus 5. Okay, and so, geez, I really don't feel like doing this, but we will. Okay, so let's go ahead and do this. Let's go ahead and distribute this x into this binomial here, and then let's go ahead and FOIL these two. So I'm going to just go ahead and combine these two, and I'm going to combine these two real quick. Okay, so it's going to be x squared plus 3x over here. Okay, and then we're going to have we're gonna FOIL the right side over there, and if I FOIL this side over here, it's going to be and again the right side being this. Okay, so it's going to be looks like x squared, and then a minus 5x and a minus x is going to be minus 6x, and then a plus 5. Okay, so all right, and the reason why I'm doing all of this out, right, is because it says that for which the coefficient of x cubed is -6. And the only way I'm going to get there to find out what the coefficient of x cubed is to actually find out what the coefficient of x cubed is, isn't it? Okay. And then I'm going to do the foiling here. Okay. So this is, it's not foiling, but it's more distributing. So this is x to the 4th. Oh man, this is what have I got myself into? Minus 6x cubed. Plus 5x squared plus 3x cubed minus 18x squared plus 15x. Okay, and then combining like terms, I got x to the fourth. My cube, so I'll mark that out. Cubes, I've got a negative 6x cubed and a positive 3x cubed, which gives me a negative 3x cubed. My squareds, I'll have a negative 15 and a positive 18. Or I'm sorry, a positive 5 and a negative 18, so I've got a negative 13x squared, and then I've got a plus 15x. Woo, okay. Now I'm at the very end. It reads, for which the coefficient of x cubed is negative 6. So how do I get this coefficient here to turn into a negative 6? That's easy. I just multiply the entire polynomial by 2, right? So it ended up being 2x to the fourth minus 6x cubed minus 26x squared plus 30x. Okay, so again, I feel like that was a nice fun exercise because it really drives the point home of, you know, we are told what our zeros are, right? And then we wrote them down here, and then, you know, the rest is just, you know, extra stuff. But that does conclude today's lecture.